All right, welcome back, friends. Good morning for those of you that are west of us. Good afternoon for those of you that are east of us. Good evening for those of you that are a long way away from us. I want to thank you for coming back and joining us today. I'm delighted that we have the one and only Viktor here to talk to us. Now, I know, Viktor, having watched you on Twitter and having been in your physical presence, which is large and intimidating, I assume you have a workout planned for later today, or perhaps you've already gotten your workout in. I did see after your big conference, you put your little hit workout on there with your Tabatas, which are shockingly hard, aren't they? I don't understand that. But anyway, I thank you so much for joining us, my friend. Yeah, well, it's all about the training, right? For 100% on that. I agree with you all the way on that. So I'm very excited to have you here. I know we have an unfortunately short time slot for you, so I'm going to go ahead and give the stage over to you. Viktor, have at it, my friend.
All right. Thank you very much, Nate. It's exciting to be here. It's exciting for another year of Spring One. Probably one of my favorite conferences. I have a handful of conferences that I not only enjoy to present, but also I enjoy to go myself. And as a developer, as a software engineer, I really like attending some of the technical talks and reach out and hang out with some of the friends in the industry because it's huge. And today I'm coming to you live from my home office. Like to say, step into my office and let's talk about Spring and Kafka and some other interesting things. So, it's not the projector. I'm sorry. I'm talking about screen sharing now. It's screen sharing is on. You see here. Just a quick check that today we're going to be talking about some of the event-driven stories told by Spring developers. My name is Viktor Gamov. I work as developer advocate here at Confluent. I like to build highly scalable and highly available Hello World applications and talk about Kafka, cloud, stream processing, Spring, Kotlin, Java, what have you. I like to talk about all these things, and I hope we'll have a good time today. All right, so I will start this talk, and I'll briefly explain some of the background around certain problems that we're trying to solve, and we will talk about the past, present, future, and we will try to also refactor one app to microservice, and I will highlight some of the patterns that I would like you to employ if you're building this type of application. All right. So when we start our application, when we start our system, it usually starts very small and very nice and cute. We start writing these small modules, small lines of codes, one package, and over the time, our system is growing, and there's different pieces of functionality coming. Different modules. We're bringing some of the new bits we would like to. We started with one serialization format. We start introducing more formats. More people start using. Over the time, our system is growing and grew very like a jungle. And very soon, the code base, all our system is becoming a darker and darker because there's so many things going on there, and many people try to work on this place. Many people work in this code. Many people contributed this code. It's very difficult to navigate, and very soon you can find even some of the dead code or some of the things that you're not happy or you're not very excited to talk about. There's all these beats inside your code jungle is going there. And this is your probably team lead or architect who likes to talk about the system or doesn't, or trying to explain this to a new guy. So the monolithic system is difficult to not only to understand, but also difficult to navigate from perspective of what is going on there, which means that refactoring is inevitable. We need to refactor the system into smaller pieces. This is what they told us, right? So we're doing this kind of stuff. We're refactoring. We're getting smaller pieces. It used to be so simple, right? It used to be so simple. We had one monolithic application runs a bunch of enterprise Java beans database, the business logic, that the Java beans, and some of the dynamic HTML pages. Not so anymore. And reason why we build the monoliths, they were normal application by that time. We didn't design the system or didn't thought about the web scale level of application development how we have it right now. Over the time, when it's like small and cute, it's easy to talk about the systems. But over the time, when you develop this and the code base becoming is gigantic, it's not so easy to talk about this anymore. It's not so easy to fit everything in one head of like one engineer or in the head of one architect. So those are also very hard to change. You need to change the system. You need to introduce new changes, but because there's so many different moving parts, and maybe it's not covered by tests, and maybe there's nothing, not very good design. So it's very difficult to change it, and difficult to introduce this change. So once we start breaking down, we know this. There's some different patterns how we can do this. It's very difficult to start figuring out how this system should look like once it will work as a whole. Since we broke this down monolith, we put this like small microservices pieces. Now, what is the way how we can reintegrate this piece? How we can, we broke down these packages. We will move these pieces of the code around, and now we need to figure out ways how we can integrate, how we can get integrated these services. There are no good ways to integrate microservices, or like, if I like to say, there are no good ways. And let's break this down a little quick. And after that, we will see what will be better. Let's start with this one, file system. I'm wondering, like, if you are in the chat, on this presentation, please write down if you ever integrated two microservices through the file system. Is it fun? I don't think so. I don't think it's a good idea, because first of all, it is not super resilient. Microservices designed to be distributed. Different services needs to be placed on different computers. In this case, you're introducing by, I don't know, a distributed file system, and they're putting data in one place and they're reading data in another place. I don't think so. It's not a good idea. Next thing is that maybe database. We will use database to communicate or like establish communication between our systems. I don't think so much. Well, let's talk about this. Let me walk you through some of the points that I have. So you might say, okay, Viktor, I do have a database and I know how to use it, and it's easy. We learned how to use this like for a while, and this problem creates the situation when these microservices, if they talk through the database, they start what I call commingle, right? So we're breaking this bounded context between the systems, and this system style depend on each other's schema inside the database. You can change the schema without notifying some other people and things like that. So what's the bounded context, you might ask? So it's kind of like a fuzzy term, but essentially defines the boundaries between your domains inside your services. So it's in one service, this domain might increase. In one service, you want to introduce, like, say, more different types of order or products, and you need to change the constantly schema to support it. But some other services that just need to know like numbers or like quantities of these products, they don't need to like expand the schema to know all these details. They know where to request it. So that's why expanding bounded context of one service doesn't necessarily need to expand the context of another one. In general, it's great to use. Your service needs to have a persistency. It's important, and it's given. You can use it. It's okay to use database inside your context. How we can get this get this data out of this context, we can talk about in a few more slides. And database is terrible for sharing data. So yes, you have ability to store your state there, but it's it's a slippery slope to start like exchanging data, like turning database into queues, for example. This is something that I've seen happen before. Right. So we can talk about the next thing is the remote procedure call, which is another approach how you can design interaction between microservices. Okay, and let's talk about this. Maybe it's not so bad, the REST or maybe gRPC or some other type of RPC communication will help. So first of all, it feels natural. Since you were writing your monolithical code by calling functions from other modules, now you kind of have a similar feeling, right? You have this module, but this module is deployed somewhere else. It's deployed in other environment where you can call this function. So you have some local stub that feels like you're calling this local function, but actually you're calling a remote. It feels natural, right? So it feels good based on request response paradigm, like just calling system one and getting response, getting there. And you as a developer don't need to change your habits because all of the things that we were developing is calling some system, getting a result. Problem. There's always a problem, and problem usually relies not when everything is good, but when everything is bad. In particular case, like some of the failures. If one of the services would be synchronous, you need to depend or be resilient. You can develop all things around circuit breakers, so your service will be resilient and have a local state, and you don't need to go to get the fresh data. You can serve some of the obsolete data to user. It's fine. But how you debug this type of system? You can say, hey, Viktor, it's easy. We will bring distributed tracing and we'll have everything lie down in one place. Does it really sound easy to you? Usually, in order to find the problems in my application, I build log. I'm writing down some of the things that I have in my log, and you can ask like log4j type of log. Yeah. Type of log. And the log4j and any type of application log is a good example of explaining what the log is. Log is immutable system that have idea how certain things are happened. And these certain things are events. And what are those events? What is that? So let's talk about this a little bit. So what is an event? So event is a occurrence of something, especially important something. There's something important happened in our system. The order created. User updated his location and address and other things. So this type of stuff is important. So for that matter, this thing is event might include some of the notifications. It might include information about just, hey, something happened, but also it can run what I call the state transfer. So essentially it might include some of the bits of state that other systems need to understand and receive this on the other side. The next thing is that events are immutable. So every time you're writing into log, you cannot change this record. That's already happened, unless you want to hide some of the things that might be not very pleasant. You go in there and change the log. But in general, events are immutable. Think about conversation with your significant other. If you said something that you're not supposed to say, there's no way how you can change it. You need to send another event. You need to send another event in order to amend the change, and it will be up to the receiver system to understand and receive your apology or whatnot. Okay, so and why it is important for me? So or for the systems, and this is where we're going a little bit technical now. Apparently, the log is very fundamental and very strong concept that can be used as a core abstraction for systems like database? No, in database we're using a table as a core abstraction. If we're using Hadoop, we're using file as a core abstraction, but it's happened to have that there's one system that was designed and created in order to support the management of these logs and make it accessible and available for many consumers and producers. So it's happened to be Kafka, and Kafka uses this concept of log as a core foundational aspect, and not like this log. That's actual photos of me doing the workouts today. But yeah, so not this type of log. The log that will capture, this is going to be a ledger that capture all these events that happened in your system, that happens with your system. So let me break down some of the quick microservice example and how this log can help these two microservices, like few microservices, to communicate. And I have this example of my implementation of Rotten Tomato system. Like if I would architect this within like the next 10 minutes, how I would architect this. So the way how it looks like, we do have a few things here. We do have the browser where the users are actually interacting with. So they go in onto the page, they click in buttons, and after that, this request goes into the web server that runs our Spring Boot application, and results will be written in database. But also, our system also wants to notify other components, and that's why it creates this like a second write. So you're writing to database and we're writing to Kafka. And after that, we start dealing with situation where we need to make sure that database is data is written to database and the data written into this like transaction log and this log. But like why we need to do this like the way we're doing this right now, which is counter. It's very intuitive. This is how you always were doing during the your like RPC design of the systems, and distributed transactions very tempting to use, but this is not how we want to use it. The way how we will integrate the system, and I'll show you in a few more steps. But also to understand how these data are structured, we need to store information about this, not inside the messages itself maybe, but from outside world, so it will be accessible for other components. Now, let's break this down again, this part, how we can access the legacy data. So this legacy data not necessarily needs to be always in sync with the same requests that come in from the browser to the web server to the database. This legacy system can be fully isolated and will be working by itself. So we don't need to create this communication directly. We might have access to this the movies database that we have by applying this thing called the connector, and the connector will connect these things for us and extract this database and turn this into event streams inside your Kafka cluster. So this is how we're dealing with legacy systems. This is we applying connector. We either listening a transaction log of this database. We're listening transaction log of database by tapping into binary log of database, or we can simply use JDBC connection to extract this data into our log in our Kafka cluster. Next thing, thanks to the frameworks like Kafka Streams, now we not only need to have an external database. Kafka Streams provides us ability to have a local state deployed next to the data. So similarly to, let me see, similarly to how our service might have an internal external database to communicate, our service might have internal, like small state store, which would be also resilient, would be fault tolerant, and would be replicated through Kafka topic. And this is the part, the good thing about this is the part of the framework that ships to you as a developer. It's not even a framework, it's a library that allows you to use any framework. Spring Boot, you can use it with Macronaut, you can use this with just a plain Java, you can use it with native, you can use the Ktor if you're in this type of jazz. So it is great. So the next thing is that we are create this local state where our ratings are calculated. Our service that will calculate ratings will replicate this data back to our transaction log with our Kafka log. And after that, the cool thing, those things happened inside application bounded context, and you don't need to have, like, I'm doing here air quotes, it's a transaction, but it's a transaction, meaning that it's not necessarily will be, transactional from perspective of like a GTA transaction, but it will be transactional from perspective of atomacy and isolation from other operation within your application code. And you don't need to worry about synchronization because it is also handled by framework itself. Now, and the last thing, this is how our architecture would look like. Even this internal small database can be updated by listening these changes from like if we update our legacy system and the movie data will be updated from here, and these changes will be propagated. These changes will be pushed automatically to our system, having this state of our rating system always up to date. And in this case, it is going to be more reactive, not reactive. It's more like we were ready to execute some stuff based on some data. It would be real time rather than request response. And the cool thing is that all this Kafka thing, it is going to be our source of truth. So every time this data is persistent, this data is always there for you, and this data will be available for consumption. When one of the services will went down, it can always replay the streams, replay this. So Kafka also behave as a event store here in our particular case. All right, for this short presentation, I really tried to teach you some of the things. So streaming service, opposed to just request response service, like a traditional microservices, might have few pattern that might might have some of the cool benefits for you. So first of all, it is allows you to decouple systems. It allows you to change how your systems communicate. Second thing is that if you learn how you can involve your existing databases like into streams, then you will change the way how you approach this data. So if you change the way how you transform data into stream, and will understand how the stream also can be transformed into table, this is going to be very powerful and really the shifting things from the way how you're thinking about the systems. Now, we will build systems with the asynchronous approach first, and everything would be asynchronous by default. In this case, we don't need to implement this circuit breaker per se. In the case of situation when we're assuming that Kafka will always be there, like event stream or event store will always be there, so you're always relying on this one, and it would be either managed by your system or like managed by your colleagues, or it would be managed by some of the the cloud providers. And data will be available immediately for many other. You start writing new application, you start writing new system. In order to get this data, you just need to have access to Kafka and access to topics, because they explain how this data look like. The order to understand this, you will just get this data from schema. And from schema, you get this from schema registry. You don't need to go and track people down, track the architects down to get this data. It will have its own schema and whatnot. Now, the immutability is the key. Data, if something has happened, you cannot change this, just like create new event. It's the key. And this approach with building connectors around this, around the Kafka and around this log or managed system of logs, allows to have a multiple system in sync by employing connectors. Now, if you want to learn more about this, so where you can go. So today I did a hands-on workshop. Unfortunately, it was quickly sold out, and many people will not be able to get in. No worries, I do have you covered. So you can go there. This is URL where you can find this description of this workshop. You can get a you can get all this the source code where you can learn more about this. Now, if you want to learn even more, just go to Confluent developer.confluent.io. Watch the full version of this video at my YouTube channel, and follow me in Twitter and ask your question there. And time for some Q&A. All right.
All right, Viktor, thank you so much, my friend. I really appreciate that. Your talk was so interesting. My cat decided to come and watch over my shoulder, although I don't know, maybe he's looking at the birdies outside. I don't know. We're going to give him the benefit of the doubt. Viktor, thank you again. Have a great weekend, my friend. Get a workout in for me today, if you will. We're going to take a quick break, stretch your legs, get some beverages, and we'll be back with Justina in just a minute.